Okay, so vectors. As this dude from Despicable Me told us, vectors are mathematical quantities that have both magnitude and direction. And I feel like the best way to kind of understand that is geometrically. So if you look at, for example, this image right here. So this is a two-dimensional vector. As you can see, it has it's in the xy plane. But you can have vectors of any dimension. You can have one-dimensional vectors, 3, 4, 120 dimensional vectors. It doesn't matter. But the most commonly seen are two-dimensional vectors and three-dimensional vectors. And so this is a two-dimensional vector because it has two components. Your x and y. So what does it mean, to say that it has both magnitude and direction? Okay, so the direction component is clearly the arrow is pointing in a certain way, and that's the direction of this vector. And the most precise way to, denote that is the angle at which the vector is at. And usually this angle is relative to this axis right here, which is typically called the polar axis. But sometimes, you'll have a vector and the angle will be relative to a different axis. And when that happens, they'll always specify. They will either draw you a picture and show you where that angle is, or they'll say, this is however many degrees north of west, or something like that. So that's what shows you the direction. And now the magnitude of this vector is the length of it. So if this vector is v, and this is how vectors are typically shown in math, the magnitude is right there. It's just the length of that vector. And you can think of this in physics, how forces are represented by vectors, and so the magnitude of that vector is just the strength of that force. So yeah, that's what your magnitude is. Okay, so now you've seen how it can be represented geometrically, but they can also be represented a few ways numerically. So for example, if we take this vector, we can see that it has an x component of 3. It goes 3 to the right, and then a y component of 4. So if we were to write this, we could write it as 3, 4, where it's kind of like a point, except it's not a point, and it's not a point because instead of parentheses, there are these angle brackets. So it's like your x and then your y. And then you can also write it as 3i plus 4j, which is just kind of the standard notation for vectors. Don't ask me why it's I or j, but it just is. But you should also know that, like I said, how vectors aren't just limited to two dimensions. The amount of just stuff here can keep going. And so typically you'll see for three-dimensional vectors, let's say, this vector is going 3 in the x-axis, 4 in the y-axis, and let's say it's going 6 in the z-axis. So if it were, then it would be a three-dimensional vector that would look like this. 6, and then you'd see the k here. But that's not the case for this vector. It doesn't go anywhere in the z-axis because, like I said, it's two-dimensional. So we would just write it like this. But, when we have a polynomial like this, we don't ever write the zeros, right? We just write, this. So that's why we don't even need to say this, because there really is no z dimension. Okay, so yeah, that's just, I just wanted you to know that if you see that, that's because it's a three-dimensional vector. And then there's one more way that typically we can write this, and like I said a few times, vectors are quantities with both magnitude and direction. So one way to represent them is by giving you their magnitude and the direction. So in the case of this vector, we can see that that's our vector. Okay, this is our vector, and excuse this awful not drawn to scale little triangle vector thing, but as you can see, if this is 4 and this is 3 and clearly it's not to scale, then this vector, considering that it's essentially just a right triangle, the hypotenuse of this triangle has to be 5, which means the magnitude of this vector is just 5. And then if we want to find the angle right there, well, we can use our trigonometric not identities, but our trig, and we can say that the tangent of this angle is 4 over 3 because it's just opposite over adjacent. So the angle itself is the inverse tangent of 4 over 3, right? And so, yeah, now we know the magnitude and we know the angle, which means that's another. We can also represent this with just the magnitude, and the angle. That's one other way to represent this. Okay, so I've shown you how to convert between the components, given the components to go to the magnitude and angle, and it's not hard to convert between these two, right? But you should know also how to convert from this. If you're given the magnitude and the angle, you should know how to go to component form. And so I'm just going to go over that quickly. Okay, so let's say you have a vector. Let's say it goes like this, and it has a magnitude. This is called vector u. It has a magnitude of 4. And it has an angle, and I will draw the angle right here, of 30. Well, if we were to redraw this vector in our little triangle here, we can, well, first off, this is it's going to be a 30, 69 degree triangle, but you always won't have nice angles such as 30. So let's do it as if this were just any angle, not a 30 degree angle. So we have, this is our y, this is our y, and this is our x. So using trig, again, we can say the cosine of the angle, or 30 degrees, is just adjacent over hypotenuse. So that's x over 4, which means x is 4 cosine 30 degrees, okay? Which is 4 square root 3 over 2, which is just 2 square root 3. Okay, so now we have, okay, yeah, sorry. Oh wow, I just realized how this is definitely not a 30 degree angle at all. But that doesn't, that doesn't matter, that's fine. So now we have the sine of this angle, 30 degrees. That's going to be opposite over hypotenuse, which the opposite to that angle is y. The hypotenuse is 4. So y is 4 sine 30 degrees, which is 4 over 2, or just 2. And so now we can convert from this, the magnitude and the angle, to our components, which are 2 root 3. And then we have to be careful here, because this angle, like I said, it's relative to this axis, yes, but typically our angles go this way when they start out relative to that axis. That's, if you notice, like your unit circle goes the other way, not here. So really, this should be a 330 degree angle, and that is because our y in this case is not positive. Y equals 2 indicates that the vector is going right and up, but it's not. It's going right and down. So this y is not going to be 2. It's going to be negative 2. And that's what happens when you don't use the angle starting from here and going around. You have to make sure that your signs are correct. And in this case, we just have to be careful about that. But if we had used the angle of 330, then our x would have been positive and our y would have been negative. So that's just completely up to you to decide what angle you want to use. But just know that if you choose to use 30, you have to remember, just be, diligent about your signs. So this would be our vector in component form, or we could write it like this, minus 2j. And yeah, that's just the basic introduction to vectors.